Assalamu alaikum dear student. Today we are going to study about stoichiometry, and this is the second question of stoichiometry. It was given in the May June 18 paper 22 question number 3C. Okay, silver chloride is an insoluble salt and silver nitrate is a soluble salt. Okay, silver nitrate is soluble and silver chloride is insoluble. So silver nitrate can be prepared. It is just information you can say. Okay, silver nitrate can be prepared by reacting silver oxide with dilute nitric acid. Silver oxide, when it is reacted with dilute nitric acid, okay, then silver nitrate is formed. Excess silver oxide is reacted, so it clears that when we have something in excess, so we cannot use it to find out the product because it is in excess. Okay, so it's reacted with the 30 cm cube of 0.150 mole per dm cube nitric acid. We have been given of nitric acid. It is not in excess, it is in limited, and this is in excess. Okay, so you can see here the volume is given and the concentration is also given. So by using its volume and concentration, we can find out number of moles of HNO3, and then we can find out the number of moles of AgNO3. Okay, after purification, the percentage yield of silver nitrate is 80%. Okay, calculate the mass of silver nitrate. What we have to find? The mass of silver nitrate. Okay, so let's start. First find out, let me write of HNO3, which is in limited, and this is in excess, we cannot use. Okay, this is in excess, we cannot use it to find out the product. We can use the volume and its concentration. So what is the volume? Volume is equal to 30 cm cube. I have to convert it into dm cube, so divide by 1000, it becomes 0.030 dm cube. Am I right? So next is its concentration. Concentration is 0.150 mole per dm cube of HNO3. This is all about HNO3. Okay, so we have to find its number of moles. So number of moles is equal to concentration multiplied by volume. Okay, concentration is 0.150 mole per dm cube multiplied by volume 0.030 dm cube. Okay, so by using calculator, you have to keep calculator with yourself. Okay, so 0.50 multiplied by 0.030. So what we get? We get here 0.0045 moles. Okay, this is the moles of HNO3, but this dm is cancelled with this dm. Okay, dm cube is cancelled with this dm, and we get mole as a unit. So now we can compare HNO3 with the AgNO3 to find out the number of moles of AgNO3, because we have to find the actually the mass of silver nitrate. Okay, so here we use the balanced chemical equation and ratio method. When HNO3 is reacted with Ag2O, so how many moles of HNO3 are used to form the AgNO3? 2 moles of HNO3 forms the 2 moles of AgNO3. If we have 0.0045 moles, what will be this? X. Same ratio will be there. Okay, let's find out. Cross multiplication. 2x is equal to 2 multiply 0.0045. You can directly cancel 2 with the 2 over here. X is equal to 0.0045 moles. What we have to find out? Mass of AgNO3. So relative molar mass AgNO3 it's given over here. Okay, is 170. Okay, gram per mole. It's molar mass. So number of moles, we know that it is 0.0045. So what we have to find? Given mass. Given mass is equal to number of moles multiplied by molar mass. Okay, so is equal to 0.0045 multiplied by 170. Okay, so multiply by 170. 0.0045 multiplied by 170. What we get over here? is equal to 0.765 gram. Okay, this is the mass. But remember that after purification, the percentage yield of nitrate is 80%. That we get 80% of this. So percentage yield is equal to 80%, mean 80 over 100. Out of 100, 80%. So multiplied with 0.765. So what we get 0.612 gram. 0.612 gram. This is the answer. So what we have done over here, we've calculated number of moles from its volume given and its concentration. Okay, so we calculated its number of moles, and then number of moles we compared of this HNO3 with the AgNO3, 2:2, and if we have this many number of moles, what will be the X? So same ratio will be there, so same number of moles are there. Okay, what we have to find? Mass of AgNO3, silver nitrate. Okay, so we have done its moles, we have its molar mass, we found its given mass, okay, by multiplying the number of moles with the mass, and this is, but what is yield? 80%, 80 over 100. Okay, so this is the answer. Question number 2. Question number 3. Silicon is non-metal found in the group 4 of the periodic table. Silicon is manufactured by reduction of silicon dioxide with the carbon. Silicon dioxide is reduced with the carbon, means it loses its oxygen. So loss of oxygen is called reduction. But it happens with the reducing agent. Carbon is the reducing agent. It reduces the silicon dioxide. Okay, and itself is oxidized. It becomes a carbon to carbon monoxide, and silicon we get. So what is the maximum mass of the silicon? We have to find the mass of the silicon. Okay, mass of silicon. What is the maximum mass of silicon that can be made from the 300 gram of silicon dioxide? 300 gram of silicon dioxide. So let's find out first, means we have to find out number of moles of silicon dioxide. Silicon dioxide. Okay, its given mass is equal to 300 gram. What we have been given. Okay, its molar mass, let's find out. Silicon dioxide. Silicon has mass 28 because it has only one atom, so that's why we don't multiply with 1. Okay, plus 16 for oxygen, and multiply 2, it becomes 32. 32 plus 28, it becomes 60 gram per mole. So what we have to get? Number of moles. Number of moles is equal to given mass over molar mass. We represent small m for given mass and m capital for molar mass. So given mass is 300 grams and molar mass 60 gram per mole. This is grams and this is gram per mole. Gram will be cancelled with the grams. Per mole will become, when it moves up, then its sign will be changed. So it becomes 5 mole. Let's find out the number of moles of silicon by the ratio method. Okay, let me write here. Silicon dioxide ratio silicon. It's 1 mole produces 1 mole of silicon. Okay, 1 mole of silicon dioxide produces 1 mole of silicon. If we have if we have its 5 moles, what will be the moles of this? X is equal to 5. With the same ratio, 5 moles of silicon will be formed. Okay, so what we have to find? The mass of silicon. Mass of silicon. To find the mass of silicon, okay, what we found first? Calculated from here number of moles. Okay, then we compare number of moles with this from the balanced chemical equation, and the second number of moles which were given. Okay, then we have calculated the number of moles of silicon. Now we have to find the given mass. For given mass, we need to know number of moles, which is the 5. We need to know the molar mass of silicon. The molar mass of silicon is 28 gram per mole, and this is mole. So given mass is equal to number of moles multiplied by molar mass. So 0.5 5 mole multiply 28 gram per mole. Per mole will be cancelled with the mole, and we will get in gram, this will be 140. Okay, of silicon. Okay, ethanol is used as a fuel. You have seen C2H5OH, ethanol. It reacts with oxygen to form the water, and the carbon dioxide plus heat is also produced. So the complete combustion of 1 mole of ethanol releases 1350 kilojoule of energy. Okay, 1350. Ethanol releases 1350 kilojoule of energy. 1 mole. A sample of ethanol reacts with excess of oxygen. Oxygen is in excess. Okay, don't worry about it. We have to find the number of moles of ethanol, because the product will be according to ethanol, which is in limited amount. Okay, which is in least amount, which controls the rate of reaction, which controls the product formed, which controls the heat released because of its lower amount, because of its least amount. Okay, so second is oxygen, which is in excess. So we don't need to, we cannot find out product from the oxygen. Okay, to make a sample of ethanol reacts with the excess oxygen to make 0.240 dm cube of carbon dioxide. Okay, we have been given carbon dioxide. So from carbon dioxide, we have to find the ethanol. Okay, so at room temperature and pressure, calculate the energy released in kilojoule. Okay, so we have given the volume of carbon dioxide. Volume is equal to 0.240 dm cube. We have to find number of moles. Number of moles is equal to given volume divided by 24. So given volume is 0.240 divided by 24. What it becomes by using calculator? 0.240 divided by 24. So it becomes 0.01. Now what we have to find from carbon dioxide, we have to find ethanol that was used, because energy is based on the 1 mole of ethanol, this much energy, then we have to find. Okay, so carbon dioxide is compared with the ethanol, C2H5OH. 2 moles of carbon dioxide are produced when 1 mole of ethanol is allowed to react with excess of oxygen. Okay, so if we have this much number of carbon dioxide, moles of 0.01, so what will be this? X. 2x is equal to 0.01 and x is equal to 0.01 divided by 2. So it becomes 0.005 mole of ethanol. Okay, this is of ethanol. So now let's find out the energy. So energy ratio mole. Now you can see if we have 1 mole, what is energy? 1350 kilojoule. Okay, because it has been given 1 mole of ethanol releases this much energy of in kilojoule. And if we have 0.005 mole, what will be the amount of energy? X is equal to 1350 multiply 0.005. It becomes 6.75 kilojoule. Okay, moving towards next question. Barium chloride, you have seen this is the barium chloride, can be prepared reacting barium carbonate with dilute hydrochloric acid. This is the dilute hydrochloric acid. When it is reacted with the barium carbonate, okay, so barium chloride is produced. That's okay. Excess barium carbonate is used. Barium carbonate is in excess, is reacted with. When we have barium carbonate in excess, so we cannot use it to find out the products because it is in excess. So what we can use? We can use ICl. So we have been given its data that we use the 40 cm cube of 1.50 mole per dm cube of hydrochloric acid. We have been given the concentration of hydrochloric acid and its volume. But remember that we have volume in cm cube. What we have to do, you understand it. Okay, so after purification, the percentage yield percentage yield of barium chloride is 75%. Means what we get theoretically, okay, it's 75% is the actual yield. Okay, so calculate the mass of barium chloride. We have to find the mass of barium chloride, and its molar mass is also given for our own ease. Okay, let's find out number of moles of the ICl, because we cannot use it. It is in excess, so we cannot use it to find the products. We can use only ICl. So volume of ICl is equal to 40 cm cube. We have to convert it into dm cube, so divide by 1000, it becomes 0.040 dm cube. Is it clear? So concentration is 1.50 mole per dm cube. What we have to find, number of moles is equal to concentration multiplied by volume. So concentration is 1.50 mole per dm cube multiplied by volume is 0.040 dm cube. Dm cube will be cancelled with the dm cube, so we can simply multiply 1.50 multiplied by 0.040. So what we get here, number of moles is equal to 0.06. Okay, so from HCl what can we find out? Barium, the moles of barium chloride. Okay, now we use the ratio method. HCl ratio of barium chloride. 2 moles of HCl produce 1 mole of barium chloride. If we have this much moles of the HCl, because we calculated from the limited volume, limited amount of the volume and the concentration of the HCl, 0.06x, it will become 2x is equal to 0.06, and x will be equal to 0.06 divided by 2. Okay, so 0.006, not 0, just 1 0, not 2 0. Okay, so 0.06 divided by 2 will get 0.03 of barium chloride. So what we have to find is mass. Given mass is equal to number of moles multiplied by the molar mass. So molar mass we have been given this one, given moles 0.03. Okay, this is the mole, multiply molar mass is equal to 208 gram per mole. So per mole and the mole will be cancelled. Okay, so simply 0.03 will be multiplied with 208. So what we get? We get 6.24 gram. This is theoretical yield, okay, which is calculated from the balanced chemical equation. But the actual yield is which is calculated, which is obtained from the, which is obtained practically, okay, which is the real. So after purification, when it is purified, so its yield is 75%. Okay, yield is 75%. So 75 divided by 100, out of 100 it is 75, then what will be 6.24? 4.68 gram. This is the answer. Gram is given. Okay, so you have 3 marks for this. First for this, second you can say for this, and third for calculating all this. We have question over here. The equation for the reaction of the iron with the steam is given. Iron is reactive with the steam. Steam is here, water is not in the liquid form, it is in the gaseous form, so it is in steam. So calculate the mass of the Fe3O4 that can be formed when the 39.2 gram of the iron reacts. So the excess of steam. Steam is in excess. So what is iron? Iron is in limiting. So remember, the reactant which is in limiting amount is used for finding or calculating the mass or the volume of the product formed. Okay. So we have been given the iron. Its given mass is equal to 39.2 gram. What's the molar mass? You can find out that is the 56 gram per mole. Okay. And what is number of moles? You can find it, you can take it from the periodic table. Given mass over molar mass. So it becomes 39.2 divided by 56. This is in gram and this is in gram in per mole. Okay. Gram will be cancelled with the gram. So 39.2 divided by 56, 0.7, and per mole will become mole when it moves up in numerator. So what can we find from here? Iron, the mole ratio we can find. Okay, number of moles of Fe3O4. Fe ratio Fe3O4. It's 1 mole is formed. Don't be confused with these 3 and 4s. Okay, these are number of atoms. We have to compare the moles which are in the start of any reactant or product. So 3 moles of this produce 1 mole of Fe3O4. If we have 0.7, then what will be x? So 3x is equal to 0.7. So here x is equal to 0.7 divided by 3. It becomes 0.233. So what we have to find? Calculate the maximum mass of Fe. So now its molar mass is not given. You know that maximum mass of Fe3O3, Fe3O4, how to find? So mass of Fe3O4 we have to find. Its number of moles is equal to 0.233, and the molar mass we have to find. So 56 for 1 iron, for 3 atoms multiply 3 plus 16 for 1 oxygen multiply 4, 64 plus what we get, 56 multiply 3, it becomes 168. Okay, so plus 64, what we get, 232 gram per mole. Okay, so by using the formula, given mass is equal to number of moles multiplied by the molar mass, and number of moles is equal to 0.233 moles, and molar mass is equal to 232 gram per mole. So per mole we can say the mole and we get in grams. Okay, so 232 multiplied by 0.233, so 54.05, 056. Calculate the maximum volume of the hydrogen and DMQ produced by this reaction. By using the same reaction, hydrogen produced. So we compare the iron with the iron oxide. Okay, Fe2O3. So same moles of the iron we can use with the hydrogen. Okay, let's see how it happens. Look here carefully. We can simply compare Fe ratio hydrogen H2. It's 3 moles produces 4 moles of hydrogen. Am I right? And if we have iron 0.7, so what will be its amount X? So 3x is equal to 0.7 multiplied by 4. Okay, so 0.7 multiplied by 4, it becomes 2.8 is equal to 3x. and x will be equal to 2.8 divided by 3, 0.933 of hydrogen. We have calculated the number of moles of hydrogen. Okay, so now let's find out its volume. So you know that volume is equal to volume of hydrogen. Okay, we have to find volume of hydrogen produced. You know what is the given volume? Volume is equal to number of moles multiplied by 24 dm cube. So number of moles 0.933 multiplied by 24, 22.4, 22.4 dm cube. This is the answer. Okay, let's do this. Iron oxide can be formed with a carbon monoxide. Okay, you can say so. Iron oxide can be reduced by the carbon monoxide. This is iron oxide. Fe2O3 is reduced by the carbon monoxide. Calculate the mass of the iron. Mass of the iron we have to find. Okay, that can be found if we have 14.4 gram of iron oxide. 14.4 gram of iron oxide. So we have been given the iron oxide its mass. Okay, mass is equal to of Fe2O3. Fe2O3. So mass is 14.4 gram. So its molar mass is equal to Fe2O3. Let's write molar mass. We have to find 56 multiplied 2 plus 16 multiplied 3. It becomes 48 plus 56 multiplied 2. It becomes 112. 112. So 112. We add 48. 160. 160 gram per mole. Okay. So now we can find out the number of moles. Number of moles is equal to given mass over molar mass. So we have the given mass. It's how much? 14.4 gram, and molar mass is 160. Okay, so 14.4 gram divided by 160, we get 0.09 mole of. This is all about the Fe2O3. So what is the mass of iron oxide? Now let's compare the Fe2O3 with the Fe. Fe2O3 with Fe. It's 1 mole produces 2 moles of Fe. 1:2. And if we have 0.09 mole, what will be this X? So X is equal to 2 multiply 0.09. 2 multiply 0.09. So 0.18. This is the mole of Fe. Okay, so now we have to find its mass. Mass is equal to number of moles multiplied by the molar mass. Number of moles equals 0.8, and molar mass, you know that of Fe is 56. Okay, simply you can find out from the periodic table. So it becomes 10.08 gram. This is the answer. Calculate the maximum volume of carbon dioxide in the dm cube produced by this reaction at room temperature. Same, by using the same ratio, we can find out the volume of the carbon dioxide produced. Okay, so by using the same ratio, we can compare now Fe2O3 with carbon dioxide. It's 1 mole produces 3 mole of carbon dioxide, and if we have this much number of moles of Fe2O3, 0.09, what will be the amount of carbon dioxide produced? Okay, in the moles. So X is equal to 0.09 multiplied 3, 0.09 multiplied by 3, this becomes 0.27, moles of carbon dioxide. So we have to find its volume. So volume, you know the volume is equal to volume of carbon dioxide. So you know that volume is equal to number of moles multiplied by 24. So number of moles is equal to 0.27 multiplied by 24, 48 dm cube. Okay, this is the question which is related to the above question. So now you can be given the question in two parts. Okay, don't worry about it. So we are going to solve the question number 8, and it has two parts as well. I hope you will be able to do yourself, because it is the same which we have already done. Same procedure is used over here, same method. Otherwise I'm ready to do it, no problem. Okay, you can find it hard, but let me do it. Potassium sulfate can be prepared by reacting aqueous potassium hydroxide with the dilute sulfuric acid. In experiments, 20 cm cube of this much concentration of sulfuric acid is just neutralized with the aqueous potassium hydroxide. So we have volume, it's given over here, its concentration is given over here by aqueous potassium hydroxide. Okay, so it means it is in excess, okay, and this is in limiting amount. Calculate the maximum volume of the potassium sulfate that could be prepared. Potassium sulfate, okay, that could be prepared. So this is the limiting. Okay, let me write here H2SO4. So volume is given 20 cm cube. To convert into dm cube, divide by 1000, it becomes 0.020 dm cube. Its concentration is equal to 0.650 mole per dm cube. So number of moles, you know that concentration multiplied by volume. Okay, concentration is 0.650 mole per dm cube multiply by volume 0.020 dm cube. Dm cube will be cancelled with the dm cube. So what we get over here, yes, 0.020 multiply by 0.650, 0.013. Sorry, number, this is number of moles, not x for now. Okay, by using this we can find out the potassium sulfate. Now let's compare H2SO4 with potassium sulfate. So 1 mole of this forms 1 mole of potassium sulfate from a balanced chemical equation. And if we have used 0.013 moles of H2SO4, what will its amount? So same 0.013 moles of this will be produced. So when we have its number of moles, we can find out its mass. So we know its relative formula mass. Molar mass is given is equal to 174 gram per mole. Given mass is equal to, number of moles is equal to 0.013. Given mass is equal to number of moles multiplied the molar mass. 0.013 multiplied by 174. Okay, it's in the mole, and this is in gram, in mole per dm cube, gram per mole. Per mole will be considered the mole. Okay, and we will get in the gram 174. So 2.262 gram will get. After crystallization, 1.72 gram of dry potassium sulfate was obtained. Calculate the percentage yield. You know that percentage yield has the formula actual yield, which is actually obtained from the experiment, from the practical. Okay, from the experiment. Okay, when we get it practically, then it is called the actual yield. And what we get theoretically is written in denominator. Multiply by 100. This is the percentage formula of percentage yield. Okay, so actual yield is what we get in real. Okay, it is 1.72 gram, and theoretical what we calculate from the balanced chemical equation. Okay, 2.262 multiplied by 100. Actual yield is the same, you can say, as theoretical yield. You can say this the result the students expect. Okay, and the actual yield is the result which the students get to know. Okay, so 1.72 divided by 2.262 multiplied by 100, 76.03% is the yield, percentage yield. Same type of question. The question which I'm skipping, you have to do yourself. You can pause the video, you can do yourself, because the same methods we have already done. Percentage by mass of potassium in this fertilizer. This thing first, the second line, this is just information. Calculating the percentage of mass of potassium in fertilizer. This is the fertilizer. Fertilizer is K2SO4. Its mass is 39 multiplied 2 for potassium, 32 for sulfur, 16 multiplied 4, 64 plus 32 plus 78. Okay, 78 plus 32 plus 64, it becomes 174. This is the mass of K2SO4. So we have to find the percentage by mass of the potassium. Percentage by mass of the potassium. Percentage mass of potassium is equal to mass of potassium in the molecule, okay, and divided by total mass of compound. Multiply by 100. Mass of potassium in compound divided by total mass of the compound multiplied by 100. Okay, so mass of the potassium is 78. You know that there are two atoms of potassium, so multiply 39 multiplied to 78. 78 divided by total mass of the compound means total mass is 174. Out of 174, 78 gram of potassium is found in the K2SO4 multiplied by 100. 78 divided by 174 multiplied by 100, we get 44.82%. Okay, let's do it. Hydrogen fluoride has a simple molecular structure. You can see this is simple molecular structure. It's soluble in water, which can be dissolved in the water. Okay, dilute hydrofluoric acid, reacts with the aqueous calcium hydroxide. So what is the minimum volume in cm cube? Is asking volume in cm cube. Remember it. Asking volume in the cm cube of 0.150 mole per dm cube of calcium hydroxide required to react completely with the solution containing 0.200 gram of HF. This is all about the CaOH twice with the HF. Okay, next, not it has no concern with the product. Reactants can also be compared with the reactants in the balanced chemical equation. Okay, so what is being told over here? Now let me tell you that what we have to do in this. Actually, we have been given of HF, given mass. We'll find its molar mass. Okay, we'll find out its number of moles. So when we find out its number of moles, then from its number of moles we can find out the number of moles of calcium hydroxide. We have been given its concentration of calcium hydroxide has been given. Number of moles we can calculate from the HF to this number of moles. Then what will happen? Then we'll find out its volume. Okay, now let me start with the HF. Okay, we have no concern with the product. We are using the reactants to compare with the reactants. Okay, so given mass is equal to 0.200 gram. Its molar mass is equal to 1 for hydrogen and 19 for fluorine. It becomes 20 gram per mole. So number of moles equal to 0.200 gram divided by 20 gram per mole. So gram will be cancelled with the gram. So given masses 0.200 divided by 20, 0.01 moles. So we can compare HF with the calcium hydroxide. Is 2 moles react with 1 mole of 2 moles of this react with 1 mole of calcium hydroxide. Okay, so if we have 0.01 mole of HF, what will be the amount of the calcium hydroxide required to react with it? Okay, so 2x is equal to 0.01 and x will be equal to 0.01 divided by 2. So it becomes 0.05 mole. So now you can see that it's we have to actually find the volume of the calcium hydroxide. Okay, we have to find its volume of calcium hydroxide. So to find out volume, we need to know its moles. Number of moles are given 0.05. We need to know its concentration. So concentration is given in 0.150 mole per dm cube. Okay, so we can find out volume. Volume is equal to concentration sorry, it's not like this. Its formula becomes like this. Let me tell you. Wait, concentration is equal to number of moles divided by volume. Okay, so volume will go there, concentration will be here. After rearranging, you will see that volume is equal to number of moles divided by concentration. Okay, same we'll do here. Volume is equal to number of moles divided by concentration. So number of moles is equal to 0.05 divided by concentration is 0.150 mole per dm cube. This is also mole. This mole will be cancelled. The mole per dm cube will become dm cube. Okay, so 0.05. This is there here as 20. Okay, divided by 0.150. It becomes 0.033 dm cube. But you know that volume has to be in cm cube. To convert dm cube into cm cube, we multiply 0.033 multiply by 1000. Okay, so simply we get 33 cm3. This is the answer. It was a bit different question because we had no concern with the product. We can use the reactant to compare the reactant. We can find out the product by comparing with the product. Okay, this is all standard. It's not necessary that we can only find the reactant with the product or the product with the reactant. Okay, this is the standard form which you have been given. Okay, you have to find the percentage table to show the urea contains a greater percentage by the mass of nitrogen than the ammonium nitrate. Urea has greater or the ammonium nitrate has. 1 mole of sulfur burns. Let us show the urea contains greater percentage by mass of the nitrogen than the when 1 mole of sulfur burns 247 kilojoule of energy is obtained. What's the question? Ammonia is used as fertilizer. It's okay. Ammonia is used. The table gives some information about the two fertilizers made from the ammonia. These are two fertilizers which are made from the ammonia. Okay. So use the table. Use the data in the table to show the urea contains greater percentage by mass of the nitrogen than the ammonium nitrate. Okay, so this is not required. Okay, this is not required. Something is extra. Okay, it might be required in the next part if there is any next part, but here we have to use the data on the table to show that urea contains greater percentage of mass of the nitrogen, percentage by mass of the nitrogen. We have to find a percentage by mass of nitrogen in urea. Now first ammonium nitrate, NH4 NO3. Let's find out its molar mass. It has 1 nitrogen 14, 4 for 4 ones are 4, and 14 for nitrogen. 16 multiplied 3, 48. So you can see 14 plus 14 plus 4 plus 48, it becomes 80. So you know that percentage of nitrogen, what it means. Mass of nitrogen in the compound divided by total mass of the compound. So mass of nitrogen is 14 plus 14. These are two nitrogen atoms. It becomes 28, and total mass is the 80 multiplied by 100. So what we get, 28 divided by 80 multiplied by 100, it becomes 35%. Let's find out of the urea. Ammonium nitrate, this is and this is the urea. Okay, urea is NH2 twice CO. Let's find out its molar mass. Nitrogen has the 14 multiplied 2 atom, 2 ones are 2. Okay, it becomes 28 plus hydrogen has 1 multiplied 2 multiplied 2, it becomes 4 atoms. So 4 plus carbon has 12 plus oxygen has 16. So what it becomes, 28 plus 4 plus 12 plus 16 becomes 60. Mass of urea is 60. Okay, so let's find out the percentage mass of nitrogen. Given mass of nitrogen is for 2 is 28, and total mass of the compound is 60 multiplied by 100. So 28 divided by 60 multiplied by 100, it becomes 46.6. So it's clear from here that the percentage of nitrogen in the urea is greater than the percentage of nitrogen in the ammonium nitrate. Question number 15. This will be the last question, I hope. Inshallah. It's enough for today. Aqueous hydrogen sulfide. You can see aqueous hydrogen sulfide because it is soluble in water, so that's why we write aqueous. React with the aqueous potassium hydroxide. Potassium hydroxide, it reacts with that. What is the minimum volume in cm cube? Remember that we have to calculate the volume in the cm cube of 0.150 mole per dm cube of KOH. We have been given its concentration of KOH. To completely react with the solution 0.170 gram of H2S means same thing, comparing reactant with the reactant. So volume in cm cube of KOH is required. We need to know the volume, and we have been given concentration. To find out the volume, we need to know the number of moles as well. So here we are using volume. We have to find of each thing KOH. Okay, volume we have to calculate, and the concentration is given 0.150, and number of moles we have to find. Okay, now let's see the number of moles. How can we calculate? Let's start with the H2S. Its given mass is equal to 0.170 gram. Molar mass is equal to 2 atoms, so 2 for hydrogen, 2 plus sulfur, for sulfur 32 has become 34 gram per mole. Okay, so number of moles is equal to given mass over molar mass. You know that is equal to 0.170 divided by 34 gram per mole. This is gram. Gram will be cancelled with the gram. Okay, you have to keep calculator with yourself. 0.170 divided by 34, it becomes 0.005. So by ratio method we can find number of moles of KOH. H2S ratio KOH. It's 1 mole forms 2 mole of KOH. So if we have 0.005 mole, then it will be okay. So X will be equal to 0.005 multiplied 2. So you will get 0.01. What is next? We have to find. We have got the number of moles n. Okay, this is what we were looking for. So we have to find the volume. You know that concentration is equal to mole per volume. Volume will come here, and then mole will be divided with the concentration. Okay, so we do it here. Number of moles which we have found right now, calculated right now, 0.01. Concentration is 0.150. This is moles. Concentration is in mole per dm cube. So mole will be cancelled with the mole. Okay, 0.01 divided by 0.150. So it becomes 0.066 dm cube. So we have to calculate in the cm cube, multiply by 1000, you will get 66 cm cube. You could have started from here. Okay, I could have started from here, and it could be the last step, but no problem, you can do. But actually I had to start from this step first, then this one, and then the volume which we had to calculate, it had to be here, but no problem, we have done it. Okay, so as I told, this is the last question. Next you have to do yourself. It's enough for today. Assalamu alaikum.